If you were driving at 70 miles per hour, it would take you about 15 days to drive around the equator, 5 months to drive to the moon, 63 years to drive to Mars at its closest point, and 4,400 years to drive to Neptune. The solar system alone is huge. In 1977, we sent a probe, Voyager 1, into space at 38,000 miles per hour, and it didn't exit the solar system until 2012. That's going 38,000 miles per hour for 35 years just to get out of the solar system. Even light, which can go around the planet 7 times in 1 second, is kind of slow when compared to the sheer size of the solar system. We are zooming out at about 500 times faster than the speed of light. Usually, it would take 8 hours for light from our sun to get this far, and we did it in about 1 minute. The solar system is absolutely massive. While the solar system is immense, it's just peanuts compared to the Milky Way galaxy. The Milky Way galaxy has approximately 300 billion stars. Some, if not most, have their own family of planets orbiting them. Our closest neighboring star system, Alpha Centauri, is 4.3 light-years away. I showed this example in a previous video, but wanted to show it again because it illustrates these distances well. If our solar system out to Neptune's orbit was shrunk to the size of a quarter, how far away do you think the next star system, Alpha Centauri, would be? Take a guess. If the solar system was shrunk down to the size of this quarter, the next star system would be 300 feet away. Earlier, I mentioned that it would take 4,400 years to drive to Neptune. Now, imagine how long it would take to drive to the next star. Even something going the speed of Voyager, 38,000 miles per hour, would take 77,000 years to get there. The next star system is extremely far away. Again, there is Alpha Centauri, and we will use this orange sphere, which represents the theoretical Oort Cloud, to show the extent of our solar system. The Oort Cloud is an immense spherical cloud surrounding our planetary system and extending approximately 1 light-year from the Sun. It's 1 or 2,000 times larger than the orbit of Neptune. For those of you wondering, this is how far Voyager has made it. Let's continue our journey. That's Betelgeuse, a star that's 640 light-years away and 1,000 times bigger than our Sun. We'll come back to Betelgeuse in a moment. As we keep zooming out, you will see the radio sphere. This is how far our earliest radio transmissions have traveled over the last 100 years or so. Our radio transmissions, although highly degraded by now, have reached about 15,000 star systems, just 1/200,000 of the stars in the Milky Way. And there is Betelgeuse again. If you look at Betelgeuse in the night sky tonight, the light that you'd be seeing left its surface about 100 years before Columbus sailed for the New World. It's been traveling that long at the speed of light and is just now reaching our planet. What's even more astounding is, in universal terms, Betelgeuse is fairly local. To blow your mind even more, our radio sphere is just a tiny blip in the Milky Way. Let's take that quarter analogy from earlier to the next level. If our solar system was again shrunk down to the size of a US quarter, the entire Milky Way galaxy would be about the size of North America. There would be another 300 billion quarters, which represent other star systems and their planets. Imagine that for a moment. Quarters spread out all over North America, approximately every 300 feet in all directions. We are just one of these 300 billion quarters floating around in this massive sea of stars and planets. Beyond our galaxy, there are at least 1 trillion more galaxies. A trillion, that's a massive number. That's 1 million a million times. Let's simplify that. Let's say you have a group of 1,000 cats, and there are 1,000 of these groups. So 1,000 groups of cats, each with 1,000 cats in them. That's 1 million cats. Now for 1 trillion, each and every single cat. Remember, there are 1 million altogether, but each and every single cat would represent another 1 million cats. That's a lot of cat fights. A trillion is 1 million a million times. It's an insanely huge number. This cat would represent 1 million cats, and this cat would represent another 1 million cats. Every cat here represents 1 million cats. That's how many galaxies are out there. Our nearest neighboring galaxy is the Andromeda Galaxy. The Andromeda Galaxy, which is 349.44 million light-years away, is currently speeding toward us at over 670,000 miles per hour. As it gets closer, our night sky will change drastically. Andromeda has about 1 trillion stars, and when it collides with the Milky Way and its 300 billion stars, it's actually very unlikely that even a single star from either galaxy will collide with one another. I'm sure this comes as a surprise to some, but that really illustrates the sheer amount of space between stars in the galaxy. It's more of a gravitational collision than an actual collision. Maybe these galactic collisions allow for life to travel between stars and galaxies. Galaxies are not the static systems we once believed them to be. They are a moving, breathing system. As we zoom out, we see our local group of galaxies and then the Virgo cluster, made up of more than 1,500 galaxies. Next, the Virgo supercluster is made up of some 20,000 galaxies. But this is just a small lobe of an even bigger supercluster, Laniakea, made up of approximately 100,000 galaxies. 100,000 galaxies, each with hundreds of billions of their own stars and planets. There are another 10 million superclusters like Laniakea in the observable universe. As we keep zooming out, you will see more and more galaxies that have been mapped out. These are real galaxies and their locations. And this is just a tiny amount of what's actually out there. There are hundreds of billions more galaxies. They just haven't been mapped out yet. The dark area is called the void of obscuration. These areas are blocked from observation by dust and other stars within our own Milky Way galaxy. As the distance gets greater, the black area or the blocked portion gets wider and wider. The red points are also galaxies. The light from these galaxies has taken so long to travel to Earth that we are seeing these galaxies as they were at their infancy billions of years ago. We are seeing billions of years into the past. In fact, anytime you look at the stars, you're seeing into the past. Finally, we get to the cosmic background radiation. This is the oldest light that we can detect, the residual heat left over from the Big Bang. What's beyond the observable universe? Many more galaxies exist beyond what we are able to see. We can't see them because the light emitted from them hasn't had enough time to reach Earth. Additionally, as space continues to expand and galaxies keep moving away from us, the light from most of these very distant galaxies will never be able to reach us. These areas may forever be out of our reach. How much further does the universe extend? By making inferences based on the laws of physics as we know them today, the entire universe is at least 250 times larger than the observable universe. It's at least that much bigger, and there are compelling arguments that it's even bigger and possibly infinite. There is a bigger picture here. What is the universe? What are we? After watching this video, you can think a couple of things. 1. I'm this tiny, separate thing on a distant planet in the middle of nowhere, special. I'll live for several decades and then die, and that will be that. Or 2, you may be thinking, wow, I'm a part of this unimaginably large, possibly infinite universe that is potentially teeming with life. A part of this thing that I don't really understand, a thing that, well, no one truly understands. A part of this planet, a part of this node in the sea of space that is coming to life. And things can get very metaphysical after that. Within our current scientific understanding, it's easy to feel alone in the universe. We believe that we are separate beings floating around on a tiny rock in a vast and seemingly dead universe. This is an old and outdated paradigm that needs to be updated. We need to re-examine a few key assumptions and learn to let go of these old beliefs for ourselves and for humanity. I'll be covering these key assumptions in future videos, but to give you a sneak peek, first, the idea that you are somehow separate from the universe needs to be obliterated. We are taught that we are individuals separate from the world out there. Of course, with assumptions and beliefs like that, you will feel like a lost soul. But it doesn't have to be that way. Although we feel that we are independent creatures roaming around, we're not really separate. We're not independent of the world we live in. We are in an intimate, inseparable symbiotic relationship with the world. Humans and nature are one and the same. We are actually a part of it, a piece of the whole. The universe is not outside of you. You are in it. You're a function of the universe in the same way that one of your skin cells is a function of your whole body. We are an aspect of the universe, so it doesn't make any sense to set yourself apart and say you're an isolated object within it. We're all one organism. It is not you and the environment as separate things. It's you, the environment, and everything around you. I'll also cover these in future videos, but here are a few more topics. The second assumption is that life and consciousness is this mysterious, emergent quality of matter that can only be experienced by a small number of select individuals on this tiny planet. The third assumption is that the universe is dead, and life and consciousness are random accidents that have little significance in the grand scheme of things. We will be diving deeper into these subjects, so stay tuned. If you have a favorite topic that you would like to see me cover, drop a comment below. If you enjoyed this video and want to help support the channel, please like and subscribe. And thank you for watching.